So in these videos, we're going to treat our functions like a formula. It's giving us this formula to follow, so how do we work with input and output? And we've worked with plugging in numbers, we've worked with solving for numbers with functions. But what happens if we put a function within a function? Or what if we do operations around the function? Basically, we're going to look at new ways of treating our function and how it changes it. And then eventually we'll talk about how it changes the domain of our function. So first off, we're going to look at how we would work with a quadratic function. So with this, we'll get a little review of quadratics and all that we can do with these types of functions. So we have our function h of t, and it's being represented by 2t squared minus 3. Something I like to do with functions is I think of it like a framework, in that if I take out what our input actually is, it could even be h of, and then we don't have anything in there, equals 2, and then we want to have this piece squared, so I'm just going to have parentheses squared minus 3. So this is how I like to visualize functions, is it gives us this framework to follow, and this is going to help as we kind of plug in more complicated things into the function. So in this first example, finding h of negative 2, this isn't anything new, it's just plugging a number into the function. So I'd have 2, my parentheses squared minus 3, and I'm plugging in negative 2, which would be 2 times a positive 4, and then minus 3, which is 8 minus 3, so we get a 5 out. So h of negative 2 is the same thing as positive 5. Now what I'm going to do in this next one is a little bit new, which is where I'm going to plug in 5t. But really we don't change much in terms of what we do. I'm still going to have 2 times my input squared minus 3. It's just where I have my input, I'm plugging in this 5t. So then with this, I'll have 2 times, and then 5t squared should be 25t squared. And then minus 3. Multiply the 2 and 25 for 50t squared. And then minus 3. And then we can't simplify any further than that. So notice that I input something with a variable, and what we end up with is an expression with that variable involved. So usually when we plug in a number, we just get a number out. But if we plug in an expression, we typically get an expression out. Now with this one, notice that 5 is on the outside. So we have 5, and I have my h of t. So h of t can just be completely replaced with this 2t squared minus 3. So what this is going to look like is we'll have 5 on the outside multiplying. I'm going to go 5, and then parentheses for multiplication. And inside those parentheses, I'm going to put my function h of t. Instead of writing h of t, I'm going to write this 2t squared minus 3. And notice for the input's just t because t was defined as the input there. So I have 5 multiplying with my function, and then I just need to distribute the 5 in. So 5 times 2 is 10, t squared, and 5 times negative 3, negative 15. And that's done. So we just multiplied our function by 5. So just take a moment to note the difference between these two examples. In this one, 5 was multiplying with our variable inside the function. So with that, it replaced our original blank spot in the function, or where t was originally, it was replaced by 5t. Here, when the 5 is on the outside and our input just stays the same, then we can see our original function, and then we're multiplying by 5 on the outside. Alright, here we have a case where we're changing the input of the function. So let's go 2 parentheses squared minus 3, and inside the parentheses we have this input of t plus 5. We have t plus 5. And then we want to avoid the most common mistake that students make. Students love to change this to t squared plus 25, but don't do it. Don't do it. And if it helps, you can always write this out as t plus 5 times t plus 5. Sometimes that just helps students realize that you need to FOIL it. That's what we need to do here. We need to go through and multiply first, outside, inner, last. So we need to multiply all of those pieces. So just be careful there that you don't just square the pieces inside. You can do that if these were multiplying with each other. But with addition, think of it expanded out like this so that you can really see that you need to FOIL. So with that, let's FOIL. We'll have t squared plus 5t plus 5t. In fact, I'll just write this out for this example. And then plus 25. And then we still have this minus 3 on the end. So to simplify, t squared plus 10t plus 25 minus 3. So, as I was mentioning with the common mistake, if students make that mistake, they miss out on this 10t term, and that's a very important term to have in there. So, need a FOIL there. Alright, we're going to distribute the 2 in. So 2t squared plus 20t plus 50, and then minus 3. And then I'll just combine those last two terms there. So 2t squared plus 20t, and then 50 minus 3, which is 47. And then we're not going to do anything else with it. We'll leave it like that. So, just to kind of summarize that, h of t plus 5 will give us that expression there. Alright, in this next example, what we can see here is this difference in outputs. We have this input was increased by 5, and then we have kind of this original input. And then the denominator, we have this kind of distance of 5. This is called a difference quotient, and it connects to slope and rate of change, and it connects to calculus too. So it's something we like to look at and practice at this point because it gives a really good foundation for calculus. It's also just a good foundation for slope and rate of change as well. Because what we're doing is we're kind of looking at how the outputs change as we change x by 5, and then down here we have this change in x by 5. It's kind of like there's this minus 0 here and a plus 0 there, just we're not writing it in. So, we'll see more of these difference quotients, and we're just practicing them now, so you'll have a great foundation with them. Okay, so, there are kind of these 3 pieces here. There's this h of t plus 5. Let's just focus on that. If I write my fraction, and I just want to write h of t plus 5, well, we just found that. So where I have h of t plus 5, I want to plug in this 2t squared plus 20t plus 47. So that's what I'm going to do. In the numerator, I'll have 2t squared minus 20t plus 20t plus 47. So all of what I wrote just there replaces h of t plus 5 that I have written in the original form. Then I'm going to go minus, and I'll use parentheses here, and then I want to have h of t. Well, h of t in its original form is that 2t squared minus 3. So I'm going to write that in the parentheses. 2t squared minus 3. So what I just wrote in the numerator there is this equivalent of that h of t plus 5 minus h of t. Just looks a lot longer because we're using the full expressions, but we have our h of t plus 5 minus h of t. And then our third piece is our denominator, which is just 5. We're not going to do anything there. So what we need to do is simplify the numerator here by subtracting these polynomials. So the first expression is just 2t squared plus 20t plus 47. And then minus, so I need to distribute the negative in there. So this will be minus 2t squared, and then plus 3, all over 5. So what we'll see, those 2t squared values are going to cancel out into a 0. We still have that 20t, and then we can combine the 47 plus 3. So that'll be 20t plus 50 over 5. And then depending how you visualize the division here, some students just start canceling here, that a 5 can be taken out of each piece. I'll just show kind of the longer form. In the numerator, we could factor out a 5, so we'd have 4t plus 10, and then divided by 5, and then you can clearly see that you can cancel out those values of 5. So all we'll be left with is 4t plus 10, and that's our difference quotient. We don't really talk about yet why or what it's doing, but that's how you would plug in values and simplify. Alright, solving. So here we have an output for our function. So what I can do is, they want me to plug in h of t right there, which we know is the equivalent of 2t squared minus 3. And we want to see that equal -1. So this turns into a quadratic equation that we're going to solve. Now this is a case where I only have t coming in as a squared value. So what we can do is use the square root property. So what I'm going to do is isolate that t squared value. I'm going to add 3 to both sides. So I'll have 2t squared equals 2. Divide 2 from both sides, so t squared equals 1. And then I'm going to take the square root of both sides. And when we do this, we need our plus or minus. And then square root of 1 is 1. We need that plus or minus because there are 2 solutions to this. And to show that, we could look at the graph. So here in red is the graph of our quadratic function, the 2x squared minus 3. So there's our quadratic. If I graph y equals -1, we can see it crosses at 2 points. There are 2 intersection points, and it's when x or t is -1 and +1. So there's 2 cases of having an output. So we need both of those answers, so we need that plus or minus. Alright, and then we have h of t equals t. So with this one, we're going to do the same thing and plug in our function. So 2t squared minus 3 equals t. And now we have our full quadratic, meaning now that we have t involved, what I need to do is get 0 on one side of the equation. So I'm going to subtract t from both sides. So I'll have 2t squared minus t minus 3 equals 0. And then I want to factor. You can use the AC method here. This one has pretty nice numbers. You could use the trial and error method. So I know I'd have 2t and t, and then I'm going to have a positive or -1, positive or -3. It should come out to 2t minus 3 times t plus 1. So we have factors. And then we're going to split into our 2 equations. So it means 2t minus 3, oh yeah, that's a good one, equals 0, or t plus 1 equals 0. I'm going to add 3 to both sides here, divide by 2, so we'll have a 3 halves. Subtract 1 from both sides over here, we have a -1. And if we wanted to, you could check these answers either by plugging them into the original equation, or if you want to look at that graph again. So with this one, I have my quadratic, and then I want to compare it to the function x, so y equals x. And with that, we can see these 2 intersection points. So we have x equals -1, so that shows up. And then we have our 3 halves there. So with that, you can use the graphing calculator to double check when you're solving equations. So that's working with quadratics. and plugging in different values and solving with a quadratic function.